Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at how to measure the electromotive force of a galvanic cell. The electromotive force is the maximum potential difference between two electrodes when no current is flowing. Now, it actually measures the driving force that pushes electrons through the external circuit. The electromotive force can be measured experimentally, or it can be calculated from electrode potentials. Now, for you to measure the electromotive force, that's the EMF, experimentally, there are certain apparatus that are needed. The first, you will require two half cells. For instance, you can make use of the zinc half cell and the copper half cell. You will also require a high resistance voltmeter or a potentiometer. You will require a salt bridge and connecting wires. Now, the importance of the high resistance voltmeter or the potentiometer is to ensure that no current is flowing and that the measured value of the EMF is actually the true value. Now, to calculate or to measure the EMF of a galvanic cell experimentally, the first thing you need to do is to connect the two half cells using a salt bridge. And then, after doing that, you connect the electrodes in the half cells to a high resistance voltmeter or a potentiometer, and then ensure that there is no external load present. After this, then you can read the voltmeter. The reading on the voltmeter is the electromotive force of the cell. It gives you the value of the EMF of the cell. Like I said at the beginning, you can also determine the EMF using electrode potentials. It can be calculated from electrode potentials. Now let us recall that electrode potential is the ability of a half cell, or is the measure of a half cell to either gain electrons or lose electrons. Now there are three different ways by which you can calculate the EMF of a galvanic cell using electrode potentials. Now, if the standard reduction potentials of the cathode and the anode is given, you can calculate the EMF of the cell, which is represented by E0 cell, using the formula standard reduction potential of cathode minus standard reduction potential of anode. Now, you're going to make use of this first formula if you are given the standard reduction potential of both electrodes, cathode and anode. Now, if you are given the oxidation potential of the anode and the reduction potential of the cathode, then the EMF of the cell is going to be the oxidation potential of the anode plus the reduction potential of the cathode. But if you are given the oxidation potential of both electrodes, anode and cathode, then the EMF of the cell is going to be the oxidation potential of anode minus the oxidation potential of the cathode. So, depending on whether you are given the oxidation potentials or the reduction potentials, you can use any of those three formulae here to calculate the electromotive force of a cell, using electrode potentials. So I want to believe that this explanation on how to measure the EMF of a cell, both experimentally and how to calculate it from electrode potentials, is clear. Thank you very much for listening, and see you in the next lesson.